I'm James Lewis, CEO of Helix Technologies. The company's been around for about 3 years and I joined 8 months ago. Pretty soon, we're all going to be dropping our car keys into the hands of a robot. And the robot's going to drive us to work while we climb in the back and do the crossword or maybe do some emails. Got to bear in mind, there'll be no steering wheel to grab. There'll be no brake pedal to hit in emergencies. We can't even give him a nudge and say, did you see that kid walking out into the road or chasing his football? How can we be sure that human safety is maintained in the world of autonomous vehicles? This isn't just a problem that we're facing. The autonomous vehicle industry is having to confront it. A lot of technology issues are being solved, but the regulatory and insurance challenges remain open. One single truth point of autonomy in vehicles is where you are. Not, I'm just outside McDonald's, but I am here. I'm here to the nearest few centimeters, that kind of distance. That's what we need. When you know that, all your other sensory systems for situational awareness all lock into place around that fundamental knowledge of absolute position. And the autonomy has to be guaranteed in the event of failure of other services. So how do we do that? Well, the companies that are providing satellite GNS services, the organizations, GPS, Galileo, etc., are putting satellites up there with ever increasing levels of encoding for accuracy. And down here on planet Earth, we've got manufacturers of GNSS receivers and chips and modules working to be able to decode those signals to provide the 10 centimeter accuracy that the industry is demanding. What about the bit in the middle, the 20,000 kilometers between the satellite and planet Earth? That's the tricky bit, and signal integrity is a real problem. The automotive industry is well aware and is very concerned by, for example, multipath problems in urban canyon environments, busy cities, metal glass structures with satellite signals bouncing backwards and forwards. That's a problem. Interference, so much electrical noise, both on the spectrum and just general interference around. And that's not to mention the issue of malicious jamming, which is a bit of a spectre of a problem that might loom. So what do? We deal with signal integrity by making a very clever antenna. Here's one. It's the smallest package that we can cram the gain and bandwidth performance required by dual band GNSS receivers. So we're receiving L1, L2 for GNSS, for GPS and Galileo E1, E5A bands. Not a broadband antenna, but actually two antennas in one with very narrow, effectively self-filtering peaks on the key frequencies. What that means is we reject all the clutter and interference and potential jamming threats that are in and around the spectrum. We deliver just the clean signal to the receiver, so the receiver can go to work and make sense and decode that signal. On top of that, the signals from the satellite are circularly polarized. When they bounce off a building, the reflected signal is reverse polarized. Because the helixes, of which there are 10, 4 on one antenna, 6 on the other antenna, wrapped around that core, are aligned with the polarization of the antenna, that means that we receive the primary signal very strongly and reject any reflected signal. So pretty much everything that gets passed through to the receiver is good, clean, clear signal. Everything else is rejected. That is the heart of signal integrity from GNSS satellite system down to receivers on planet Earth. Armed with that data, we can now enable the autonomous vehicle and other industries, a lot of interest from military and aerospace, drone applications as well. We can enable 10 centimeter accuracy in a dynamic, fast moving environment from our antennas. Stage we're at right now is we are late stage prototyping. We'll be launching products before the end of this year. We've got lead customers in the military and in aerospace. In fact, ESA is a major early customer of ours. We are a classic startup at the moment with plans to expand rapidly over the next year. The business model is an outsourced, licensed manufacturing model. We've had to invent a highly complex manufacturing process to be able to make these antennas with the precision that they require. So for a startup, the opportunities provided by the Bessemer Society in terms of networking and just being able to make contact with and work with other CEOs who are in this sector, in adjacent sectors, upstream and downstream from us is hugely valuable, and really looking forward to making best use of the society